Do you even wonder seeing mechanical engineering products in your day-to-day life? For example, I woke up in the morning and checked the clock on the wall. The hands movement on the clock is the product of mechanical engineering. I realized I'm already late and rushed into the bathroom to brush my teeth, and I closed the door. The door only got closed because of the hinge. That hinge is also a product of mechanical engineering. I felt thirsty and took a Gatorade bottle from the refrigerator to drink. That refrigerator is also a product of mechanical engineering. I got ready and left to college on my bike. That bike is a product of mechanical engineering. Cars, elevators, fans, and ACs. These are only few of the mechanical engineering products that we see today. Not only products, but also we apply some basic mechanical engineering principles in our everyday lives. For example, want to save gas, reduce tire wear and overall maintenance costs on your car? Just minimize brake usage by relying on Newton's law of inertia. Newton's law of inertia states that all objects that are at rest tends to stay at rest unless acted by a non-zero net force, and that all objects that are in motion tends to stay in motion unless resisted by a non-zero net force. Second, do you want to capture more energy and stay warmer during winter? Easy. Just wear a black jacket or coat and a white t-shirt underneath. And this scenario talks about heat transfer. So now we ask, what is mechanical engineering? Mechanical engineering is one of the most versatile and diverse among all other engineering fields. And mechanical engineering is also the study of objects and systems in motion, such as the field of mechanical engineering touches virtually every aspect of modern life, including the human body and highly complex machines. Mechanical engineering has a wide scope of topics, so it is very important to know the core concepts when taking this course. So, let's move on to the 7 fundamentals or basic concepts in taking mechanical engineering. Some of these topics were not only for mechanical engineering, but also covers for some other engineering courses. Number 1 is the basic terminology and concepts used in mechanical engineering that serves as a very important stock knowledge to mechanical engineers. For example, like work, heat, power, energy, force, friction, density, and heat capacity. Work is the measure of energy transfer that occurs when an object is moved over a distance by an external force, at least part of which is applied in the direction of the displacement. Heat is the flow of energy from a warm object to a cooler object. It can be released, absorbed, or transferred. Heat energy is also the result of the movement of tiny particles called atoms, molecules, or ions in solids, liquids, and gases. Power is the amount of energy transferred or converted per unit time. Energy is the capacity of doing work. It may exist in potential, kinetic, thermal, electrical, chemical, nuclear, or other various energy forms. A force is a push or pull that acts upon an object as a result of that object's interactions with its surroundings. Friction is the force resisting the relative motion of solid surfaces, fluid layers, and material elements sliding against each other. The density of a substance is its mass per unit volume. And lastly, heat capacity is the number of heat units needed to raise the temperature of a body by 1 degree Celsius. Some core concepts include the mastery in mathematics, especially in calculus, thermodynamics and heat transfer, physics, material science, fluid mechanics, and structural analysis. Next, it is also important to familiarize the basic units used in engineering quantities for conversions, like meter for length, kilogram for mass, seconds for time, liter for volume, ampere for electric current, Kelvin for temperature, candela for luminous intensity, and mole for quantity of substance, and many more. From these basic units, there are also some useful derived units that have been defined. For example, Newton for force, joules for work, energy, and heat, Pascal for pressure and stress, and Watt for power, and many more. Aside from terminologies and units, it is also important to familiarize engineering formulas and known theories for computation, especially for mechanical engineering. These formulas and theories include the computation for strength of materials, heat and transfer, manufacturing, fluid mechanics, thermodynamics, machine design, theory of machines, industrial engineering, and engineering mathematics. Mechanical engineering requires both critical reasoning and analysis and proficiency in mathematics, not just being proficient in one of the two, so it's very important to be proficient in both areas. Technically, the basic concepts involved in mechanical engineering involves the basic knowledge in terminologies, units, formulas, theories that were conglomerated into one package and serves as a fundamental knowledge pillar for aspiring mechanical engineers.
Number 2. The basic engineering materials. The knowledge of engineering materials and their properties are great importance to mechanical engineers. Engineering materials are classified as 1. Metals and their alloys such as iron, steel, copper, and aluminum. And 2. The non-metals such as glass, rubber, and plastics. Metals can also be further classified as ferrous or non-ferrous. Ferrous materials are those who have iron as their main constituent, such as cast iron, wrought iron, and steel. On the other hand, non-ferrous materials are those who have metal other than iron as their main constituents, such as copper, aluminum, and brass. Mechanical engineers don't necessarily have to know all the deep science material details such as the atomic structures and others, but it is important to have a good knowledge of the material properties that will affect the performance of your desired system. Number 3. The common engineering material properties. These material properties are strength, stiffness, elasticity, plasticity, and others. However, the 8 material properties that mechanical engineers are always concerned of are elastic modulus, which affects stiffness, which determines deflection under load. Density, which weight is almost always a concern. Fatigue properties, if your components will be cyclically loaded over a long period of time. Fracture properties, which depends on the specific material, environment, and loading condition. Corrosion, which depends on the environment as well as the materials of the other parts in the system. Hardness, which is a concern for wear and galling when you have two materials sliding on one another with an applied pressure. Coefficient of thermal expansion, which is a concern if the operating temperature is variable. And lastly, the weldability, which is important if you are creating structure that is intended to be joined by welding. Most mechanical engineers work building products that need to be delivered according to a budget and a schedule, so the cost of the material, availability of a material, and factors relating to manufacturability are all important. Since every mechanical system are built with materials, it is important to have a good grasp on how they behave. Number 4. The basic machine elements. Machine elements was traditionally be seen as mechanical parts, mostly used as the building blocks of machine design. These are inclined plane wedge, gears, spring, combs, levers, wheel and axle, belt and pulley, and chain and socket, and many others that make up a machine. Number 5. The basic equipment used in mechanical engineering. Mechanical engineers work on power-producing machines such as electric generator, internal combustion engines, and steam and gas turbines. They also work on power-producing machines such as refrigeration and air conditioning equipments, machine tools, material handling system, elevator and escalators, industrial production equipments, and robots used in manufacturing. There are also some mechanical engineers that design tools for other engineers need for their work. In addition, Mechanical engineers can work in manufacturing or agriculture production, maintenance, or technical sales, and many can also become administrators or managers. Of course, when there is machines, it is also essential for the mechanical engineers to know basic concept when it comes to maintenance in machineries. Machine maintenance is the work that keeps mechanical assets running with minimal downtime. Machine maintenance can include regularly scheduled service, routine checks, and both emergency and scheduled repairs. It also includes replacement or realignment of parts that are worn, damaged, or misaligned. Machine maintenance can be done either in advance or failure or after failure occurs. Machine maintenance is critical at any plant or facilities that uses mechanical assets. It helps organize meet production schedule, minimize costly downtime, and lower the risk of workplace accidents and injuries. Lastly, the fundamental concept when it comes to drawing. Mechanical engineering drawing are technical and skilled drawing that helps define and illustrate specific mechanical requirements and processes, like how we see machine blueprints or plates by other mechanical engineers. Other than mechanical means in drawing, there are also some specialized computer softwares that helps to create computer-aided designs. For example, by using the CAD software for creating 3D or 2D detailed modification, it can create more detailed and precise representation of a design, and it is also a tool that is a great help to mechanical engineers.
Now we have tackled over the basic key concepts in connection to this course, so we will move on to the question, why does the world need mechanical engineering? The modern world comes with a lot of moving parts. From the way that a wall clock takes away the hours of the spinning of car wheels on their axles, it takes many precise pieces and movements to keep things running smoothly. While it takes many hands and machines to put together something so complex as a car, those hands know what to do because of a mechanical engineer. Though it may not be a discipline that most people spend time thinking about, mechanical engineering is critical to so many aspects of everyday life. Indeed, mechanical engineering is one of the oldest scientific disciplines and can be traced back centuries to the great thinkers of ancient Greece like Archimedes. Ultimately, most things that we use today that involves any type of moving or static parts comes and evolves. Even the development of more sophisticated electronics and other technologies will depend at least in part on mechanical engineers. That is why mechanical engineering is an interesting and essential area of concentration. Branches and disciplines under mechanical engineering. Because mechanical engineering is a broad topic, there are many engineering specialties that can fit within its scope. Some of the most common mechanical engineering branches where graduating students can find careers include acoustical engineering, for the manipulation and control of vibration in order to reduce unwanted noise, manufacturing engineering, for optimizing manufacturing techniques, developing processes as well as machines, tools, and equipment for the manufacture of goods, thermal engineering, for creating and maintaining comfortable and safe environments through the control of heating and cooling systems, vehicle engineering, for the design and manufacture of all manner of vehicles, and aerospace engineering for vehicle engineering as specific to air and space travel. In some instances, other specialties fall within the purview of mechanical engineering as well. For example, the Stanford graduate program in mechanical engineering is one of the world's top institutions and features those specialties in biomechanical engineering for the application of engineering theory to medicine, design engineering for the use of mechanical engineering theories to design better machines that promote efficiency as well as sustainability, flow physics and computational engineering for the intersection of sciences, engineering, mathematics, and computer science, mechanics and computation engineering for the application of mechanics to solids, fluids, biological tissues, and complex materials, and thermoscience engineering for the use of engineering to create, harness, and conserve energy. Undergraduate students are largely not expected to choose a specialty, but those who decide to go onto a graduate program should be prepared to focus on a very specific area of mechanical engineering. After knowing about the basic concepts of mechanical engineering, now we ask, what skills do mechanical engineers need? According to Michigan Tech, the essence of engineering is problem solving. With this at its core, mechanical engineering also requires applied creativity. With hands-on understanding of the work involved, it goes along with strong interpersonal skills like networking, leadership, and conflict management. Creating a product is only part of the equation, but knowing how to work with people, ideas, data, and economics fully makes a mechanical engineer. Also, according to many employers and target jobs, it is essential for mechanical engineers to have these 8 key skills, namely 1. Having effective technical skills, 2. Having the ability to work under pressure, 3. Proficient in problem-solving skills, 4. Number creativity, 5. Smooth interpersonal skills, 6. Proficient in verbal and written communication skills, 7. Commercial awareness, and 8. Team working skills. Despite all of these skills, every mechanical engineer has their own role in the society. Now, what tasks do these mechanical engineers do? Careers in mechanical engineering call for a variety of tasks. Some of these tasks are conceptual design, analysis, presentations and report writing, multidisciplinary teamwork, concurrent engineering, benchmarking the competition, project management, prototyping, testing, measurements, data interpretation, developmental design, research, analysis, working with suppliers, sales, consulting, and customer service. Mechanical engineers are critical to the inner workings of today's society. Mechanical engineers research, design, develop, manufacture, and test a variety of mechanical devices, including tools, engines, and machines. Ultimately, anything that can be imagined, designed, and built has an aspect of mechanical engineering to it. Mechanical engineers work across a huge variety of industries conceptualizing, designing, and creating machines as well as their components. Though it is one of the oldest engineering disciplines, it is also one that continues to change and grow with advancement in technology, making it a vibrant and exciting career path even to this day.